All right, here's 1.1.15, and this question is asking us in the diagram, the measure of angle LMN is 116, the measure of JKM is 122, and the measure of JNM is 103, and it wants us to find the measure of angle NKM. I had a lot of requests for this one, and the reason I assigned it is when I did this, I did it very quickly, and for NKM, I actually highlighted NKJ when I did it, and I moved right on. And it's actually not asking for NKJ, so it's asking for NKM. NKJ has that double congruency mark, so when I found the value of the double congruency mark, I moved right along. But that's obviously not what the question's asking, so I went ahead and assigned it. But I assigned it without you having one vital piece of information about the sum of the interior angles of a triangle. Interior angles just mean the angles on the inside. And that very important piece, is this right here. The sum of the interior angles of a triangle add up to 180 degrees. This is also one of the most important things in geometry for this year, and you're going to use it quite often. So now that we know that, let's see if we can make a little more sense out of this. I'm going to start by color coding as usual, and I have the measure of angle LMN is 116. So I'm going to actually go ahead and say L to M to N is 116. That's this whole angle here. And that's 116. Let's make that a better 6. All right. Then I have JKM is 122. So let's highlight that in a different color. So for JKM, I'm going to call that 122. So from J to K to M is 122 degrees. And in a new color again, JNM is 103 degrees. So J to N, wow, went from perfectly straight lines to whatever that was. J to N to M, that whole thing is 103 degrees. So now we're going to start looking at some of these things to see if we can figure anything out. And what immediately draws my eye is that I have LMN at 116 degrees. That's the whole angle here. And I have these congruency markers that tell me that this angle here and this angle up here are exactly the same, right? They're congruent. Was this K here before we colored it? Yeah. So I'm just going to write K here real quick. So KMN and KML are congruent. So if I can solve for those, I will know what the value of the one tick mark is. Well, one of the nice things when you have two equal things is you can divide their overall value by 2 and you get their independent values, right? Think of it as their average. And what I mean by that is, let's call, we know in this diagram KMN and KML are congruent by these two tick marks. So I'm going to call KMN X, and that means that KML is also X, and they're equal. So what I have here is X plus X, right? That's these two angles, KMN and KML, must equal LMN because it's the overall encompassing angle. And I can solve for this by combining like terms here, and then solving for X by dividing by 2, and I get X equals 58. So anywhere I have a single tick mark, so I'm going to call that T1 for tick mark 1, I can plug in 58 degrees. Now I need to figure out what is tick mark 2. Well, if I go to JNM, I know that the value of J and M, the whole thing here, is 103 degrees. And I know that J and M is equal to the two angles that are adjacent to each other that cut through J and M at N and go to K. So I know that I have J and K plus K and M to get J and M. Now right here, I can see that J and K has one tick mark. So I can substitute the value of a single tick mark that is 58 degrees here. And I know J and M is equal to 103 degrees. So all that's left is trying to solve for K and M, which is our double tick mark, right? Well, our double tick mark is our unknown now, so I'm going to make that X. And then I'm going to balance this by doing minus 58. And 103 minus 58 is 45. So now I know that here, this blue X is equal to my tick mark 2's value. So I have 45 here. Now, this is where maybe most of you got to before you thought, I have no idea how to proceed from here. And I do apologize for doing that to you. But what we're ultimately looking for is the measure of angle NKM. I'm going to go ahead and highlight that one in green just so we can see what we're looking at. So if I start at N and I go to K and then I go to M, I'm looking for the angle right here. Now, what I have for JKM is 122 degrees, so I know the whole angle is 122 degrees. And then from my two tick marks here, I know that I've already pulled out 45 degrees, so I can do minus 45. And what does that leave me with? NKM, which is exactly what we're looking for. So back to my calculator, 122 minus 45 is 77, and that is the measure of angle NKM. And now I want to check my work. And to do that, well, let me get another copy of this really quick. Alright, so now we have our fresh one here. And I know that if I see one tick mark, it's going to have a value of 58. So I'm going to, we already did green. Let's go to this color. So I know one tick mark is 58 degrees. I know two tick marks is 45 degrees. And my conclusion was that this should be 77 degrees. To check that, I can go back to this fact right here. The sum of the interior angles of a triangle is 180. And I can do 45 plus 58 plus 77 and set that equal to 180 because that's what it is inside of a triangle. And if this equation is true, then we are good to go. And in fact, adding these all together gives me 180 is equal to 180. And we were able to find the measure of NKM at 77 degrees. We were also able to go back here in this reddish purple color and verify that the sum of that triangle's interior angles is 180 degrees.